There is a foundation trick so cheap, most builders could add it for less than the price of a dinner. Yet this simple method can stop the kind of hidden moisture damage that leads to cracked walls, mold-rotting finishes, and repairs worth thousands. It is not futuristic. It is ancient. For generations, builders understood that water does not need a flood to destroy a house. It only needs time pressure and one path inward. But then something strange happened. The knowledge disappeared. And once you see how this old method works, you may also understand why so many modern homes are still built to fail. Moisture damage rarely begins with a dramatic collapse. It begins silently. A faint stain near the floor. Paint that bubbles for no obvious reason. A musty smell that returns no matter how many times the room is cleaned. Hairline cracks, soft baseboards, white salt marks blooming across concrete and brick. Most homeowners see these as separate problems. They are not. They are often different symptoms of the same hidden force water moving upward and inward through the foundation of the house itself. That is what makes this so expensive. By the time the damage becomes visible, the process has usually been happening for months, sometimes years. And once it starts, every layer above the foundation begins to suffer. Plaster breaks down, wood swells, mold spreads, interior finishes fail, repair costs multiply. Modern construction claims to have solved this with coatings, membranes, sealants, and chemical barriers. But if that were true, why is foundation moisture still one of the most common and costly problems in residential buildings? That question matters. Because long before branded waterproofing systems existed, builders in wet climates were already controlling ground moisture with low-cost methods based on one simple principle. Never let the water enter the structure in the first place. Long before modern developers poured slab after slab from standardized plans, builders in floodplains, monsoon regions, river valleys, and coastal settlements had already learned a hard truth. The ground is never truly dry. It may look solid. It may even feel safe. But beneath every house, water is always moving. Ancient builders understood this not through laboratory instruments, but through failure repeated across generations. They saw walls darken from below. They watched floors sweat during humid seasons. They saw plaster crumble where the soil stayed wet longest. And over time, they developed a building logic that treated moisture as a permanent enemy, not a rare accident. In parts of the Roman world, foundations were often raised above grade and supported by compacted stone layers designed to separate the structure from wet earth. Across the Middle East and North Africa, builders used lime-rich mortars and breathable masonry that allowed trapped moisture to escape before pressure could accumulate. In South Asia, traditional homes were commonly elevated on plinths with drainage paths and graded surroundings that pushed rainwater away from the base of the structure. Different cultures used different materials, but the principle was the same. Break the path between the wet ground and the house. That idea appeared again and again in old building traditions. Builders laid coarse gravel beneath floors. They created rubble trenches around foundations. They used stone bases below earthen or brick walls. They inserted layers that were not meant to seal water completely, but to interrupt its upward movement. Some relied on air gaps, others on capillary breaks, others on lime sand, fired brick, and carefully chosen aggregates that managed moisture rather than pretending it did not exist. This was not luxury construction. It was practical knowledge. And because it was practical, it spread widely. Villages used it. Temples used it. Farmhouses used it. Workshops used it. The technique survived because it saved structures from slow destruction especially in climates where rainfall, groundwater, and humidity made moisture inevitable. Then industrial construction changed the equation. As cities expanded, building became less local and more standardized. Speed replaced adaptation. Materials were selected for cost, transport efficiency, and ease of mass use. Concrete made building faster. Uniform designs made planning easier. Chemical coatings promised simpler protection. And gradually, old moisture control strategies were either reduced, simplified, or removed altogether. Not because they were useless, because they were inconvenient to an industry obsessed with speed. A raised plinth takes planning. A drainage layer takes thought. A breathable assembly requires builders to understand how water actually moves. But a fast pour, a sealed surface, and a promise of waterproof performance can be sold much more easily. So the ancient logic faded. Not all at once, but enough. And that is why many surviving old structures still reveal something uncomfortable. Builders with fewer machines, fewer chemical products, and fewer branded systems often understood foundation moisture better than many modern contractors do today. They knew the house does not begin at the walls. It begins at the ground. And if the ground is wet, everything above it is already at risk. To understand why this foundation method works, you need to understand how water actually enters a house. Not from one dramatic leak, from microscopic movement. Most building materials used below and near ground level are porous. Concrete, brick, mortar, stone, and even some renders contain tiny channels and voids. These spaces may be invisible to the eye, but they are large enough for water to travel through. This is where the real problem begins. When soil beneath or around a house is wet, moisture does not simply stay in the ground. Through capillary action, water can move upward through narrow pores in the same way a paper towel pulls liquid against gravity. The smaller the pore space, the more effectively water can climb. That means a dense-looking wall or slab can slowly draw moisture upward from the earth below, even when there is no visible pooling water. Then pressure makes it worse. When the surrounding soil becomes saturated after rain, hydrostatic pressure builds around the foundation. That pressure pushes water laterally into cracks, joints, cold seams, and weak points in the structure. So now the building is being attacked from two directions at once, upward through capillary rise and inward through side pressure. This is why surface fixes often fail. Paint can hide symptoms. Sealants can delay entry. Membranes can help in specific conditions. But if moisture is already being fed continuously from the ground, many surface-level solutions are fighting the last stage of the problem, not the first. The cheap foundation trick works by interrupting the water pathway before the structure becomes the pathway. That interruption is often created with a capillary break. A capillary break is a layer of material with pore spaces too large, too irregular, or too discontinuous for water to climb effectively. Coarse gravel is a classic example. Unlike compact, fine soil, gravel contains large voids. Water can drain through it downward and sideways, but it cannot easily bridge those air gaps and continue rising upward with the same force. In simple terms, the moisture loses its ladder. That matters, because once the upward path is broken, the foundation above stays dramatically drier. The same logic applies to drainage layers and foundation detailing. If water is directed away from the building with slope gravel drainage channels and relief paths, hydrostatic pressure drops. Less pressure means less forced entry into the structure. If breathable materials like lime-based mortars or plasters are used, any residual moisture that does enter can evaporate out instead of becoming trapped behind dense, impermeable coatings. And trapped moisture is often the hidden modern mistake. When a wall or slab is sealed with non-breathable finishes, the water does not disappear. It accumulates. Salts crystallize. Coatings blister. Mold finds organic surfaces nearby. Wood components absorb the damp. The damage spreads upward even though the source remains below. So the science is not mysterious. It is physics. Water follows pressure-pore structure and the easiest available path. Ancient builders succeeded because they respected that reality. They did not try to argue with moisture. They redirected it. They broke its pathway, relieved its pressure, and allowed the structure to breathe. That is why a cheap layer of stone-gravel airspace or breathable mineral material can sometimes protect a house more effectively than expensive systems applied after the damage has already begun. If this method is so simple, the obvious question is unavoidable. Why is it missing from so many modern homes? The answer begins with incentives. Modern construction is not designed around maximum long-term durability. It is designed around speed standardization code, minimums, labor efficiency, and immediate cost control. Developers make money by finishing faster. Contractors stay competitive by simplifying details. Material suppliers profit when systems are repeatable, branded, and easy to scale across thousands of projects. A cheap preventive layer hidden beneath a foundation does not look impressive in a sales brochure. It does not photograph well. It does not create an upsell. And because homeowners never see it, many never ask for it. That makes it easy to remove. Once that preventive thinking disappears, an entire chain of profitable problems begins. Moisture enters. Finishes fail. Waterproof coatings are sold. Crack repairs are sold. Mold inspections are sold. Interior repainting is sold. Damaged flooring is replaced. Rotten trim is replaced. Basement treatments are sold. Structural remediation is sold. The same house can generate years of recurring revenue simply because one basic moisture control principle was ignored at the beginning. That is the business model hiding in plain sight. In many countries, the repair and waterproofing market is worth billions of dollars annually, fed not just by extreme structural failure, but by ordinary repeated moisture damage in homes that were supposedly built to modern standards. The more common the problem becomes, the more normal it appears. And once it appears normal, fewer people question whether it was preventable from the start. That silence matters. Because a solution that costs little uses ordinary materials and lasts for decades is difficult to monetize after the fact. It cannot generate the same recurring service cycle as chronic moisture problems. It does not depend on proprietary chemistry. It does not require homeowners to keep buying treatments every few years. What cannot be turned into recurring revenue is often neglected or forgotten. They did not bury it because it failed. They buried it because it worked too well. Not through a secret meeting in a dark room, but through something far more powerful, an industry structure that rewards fast construction, profitable repair, and short memory. Over time, the old method became invisible, not because it was unscientific, but because it solved the problem too early. And a problem solved at the foundation is a problem no one gets paid to fix later. So, what does this mean in practice for someone building or renovating a house today? It means the smartest moisture protection often starts before the concrete is poured. First, water around the house must be controlled, not ignored. The ground should slope away from the foundation so rain does not collect at the base. Roof runoff should discharge far enough away that it cannot soak back into the soil beside the walls. Around and beneath the foundation, coarse gravel or similar free-draining material can create a capillary break and reduce water pressure before it reaches the structure. Then comes material logic. Where possible, the assembly should avoid trapping moisture. Breathable mineral-based materials can help residual damp escape, while overly sealed finishes in vulnerable areas can sometimes make hidden moisture worse. Foundation details should be designed to separate wet soil from absorbent structural materials as much as possible. The principle is simple. Do not wait to waterproof the symptom after the house is damaged. Stop the moisture pathway at the beginning, because once water enters the structure, every repair becomes more expensive, more cosmetic, and less effective than the cheap preventive detail that could have blocked the problem from the start. One of the most expensive problems in home construction was never just water. It was ignorance. A house does not fail only when the roof leaks or the wall cracks. It begins to fail when builders forget that moisture starts below, moves quietly, and destroys slowly. The old foundation method was cheap, simple, and effective. That was the problem. If you made it this far, you now understand more about this topic than most people ever will. Subscribe and share this with someone who deserves to know the truth behind it.